For this problem, we are given 12x cubed plus 13x squared minus 1. We are given one of the zeros, f of 1/4 equals 0. And so we want to do these three parts that we've been doing already in this section. Okay, so first we want to use the rational zero theorem to find the list of possible zeros. So this is, again, factors. So we have factors of -1, the very last number, over factors of 12. Okay, so on top, we're going to write the factors of -1. So that's just going to be just basically plus or minus 1, and that's going to be it, actually. So that's the only one on top. On the bottom, we have factors of 12, so plus or minus 1, plus or minus 2 is a factor, 3, 4, 6, and 12. So we have all 6 of these are going to be factors. So now we want to write the list of zeros. So you're just going to take 1 and divide it by everything that you see here. And we'll just do the plus or minus in front of each one. So plus or minus, we have 1 over 1, so just 1. Plus or minus 1 over 2. Plus or minus 1 over 3. Plus or minus 1 over 4. Plus or minus 1 over 6. And plus or minus 1 over 12. As you can see, we are given one of the zeros, so 1/4 definitely would come off of this list here. But we don't have to test every one of these because we already know that that one's provided. We don't even need to do a graph either because they gave us that one. All right, so now we're going to use the given zero with synthetic division. So 1/4 is what we're going to put outside the box here. We're not going to take the opposite sign because it doesn't come from like an x plus or x minus something. We're just going to use the number inside as is. Now, something to notice about this, the 12, 13, notice that we are missing an x term that's there. So we have to put in a placekeeper for this. So I'm going to do 12, we have 13, but then we have a 0 on there. There's no x term, 0, and then -1. So let's move this up. So this is what you should have when you do the setup on that. We have a placekeeper here because, again, the x term is not there. All right, so let's drop down. So synthetic, we drop down the first term, so 12. We multiply that together and put the result in the next column. 12 times 1/4 is going to be 3. We're adding always when we do synthetic. 16 on 1/4, we get a 4 there. Add this together, 0 and 4, get a 4 there. 4 times 1/4 is 1. Add it together, and as expected, we get a 0 as our remainder, which you should always get for problems like this. Now, what's left over is going to turn into a quadratic because originally it was a cube, and now every time you do synthetic, it drops the power down by 1. So now this is going to be 12x cubed, or squared rather, 12x squared plus 16x plus 4, and that's going to be equal to 0. What I do notice about this is there's a common factor of 4. So I'm going to first begin by factoring it out. So I'm going to get a 3x squared here plus 4x and then plus 1. Now, I don't want to divide both sides by 4 here because I'm going to use part of this answer in B. I'm going to use it again for part C. So that's why I don't want to divide everything out. And this is also why you don't want to use quadratic formula in part B, because the part that you have here, you're going to use again for part C. So it's better to factor this one in part B. Okay, so let's take a look next. Let's go ahead and factor this one. We can use the trial and error method on this here. So 3x and x is there, and then I have 1 and 1, and all these would need to be positive because this one's positive. Let's see if that actually works. So 3x times x is 3x squared. We have a 3x and a 1x gives you a 4x there. 1 times 1 gives you a 1. So yes, this is factored correctly. So now we just need to set all this equal to 0. Now, of course, the 4, we can't set that equal to 0. There's no variable in it, so 4 can't equal 0. But these other ones we can do. 3x plus 1 equals 0, and x plus 1 equals 0. So if we solve each of these, subtract 1, divide by 3, we get negative 1/3. And we also get negative 1. Now, both of these here were from the list that we did up here before. We have the 1/3 and we have the 1. So again, all these come from our original list that we had. But these are going to be our the other zeros that it's asking for. Okay. So now that we have that, we need to use these answers to factor the polynomial. The first thing that you're automatically going to have is this whole piece here that we've previously factored. Okay, so this part, that's why you want to factor in part B, because that part is automatically used in your answer. So now we have that. Now, the next thing is we have a 1/4 that's here that was originally given to us in this problem. So whenever you want to create a factor, you always want to do x minus whatever the 0 is that they gave. Okay, so now we have x minus 1/4. Now, you usually don't want to leave your answer like this if we have an extra fraction that's there. So what we're going to do is we're going to move this part next to the 4. So I'm just going to rearrange. You can do this with multiplication. You're allowed to change the order around on that, and it's still going to be the same. All right, so now we have this. Now, the reason why I put this part next to the 4 is because the 4, I can now distribute into each of those. Now, a common question that comes up is, why do I just multiply the first one? Why don't I take the 4 and multiply it all the way through every single one like that? Well, that's because there's no plus or minus signs in between these. If it's multiplication, you just multiply 2 at a time. So I could take the 4, I could have done 4 times this one only, or 4 times this one. It's whatever one I have. I'm just going to multiply them just 2 at a time when you do these kind of problems. So I'm just going to multiply this part only. The 4 does not distribute to these other ones that you have here. So you're going to get 4x minus 1. And then we have 3x plus 1, x plus 1. Okay, so this would be now fully factored, and we don't have the extra fraction there. So if you have a fraction like this, typically you're going to have this other number that's going to appear out front. So that's usually what happens when you get a fraction like this. You're almost always going to have a number out front like that that's going to cause you to be able to cancel out the fraction through multiplication. So now this is how you want to make it. You don't want to have any fractions in your answer. You just want to have linear terms like we see here.